It's all pretty impressive when you consider just a few years ago, nobody was thinking about thinking.
Do you ever think about things? No, you don't think about things? Only your mommy does? You know what thinking is?
No.
No. And your dreams come from where?
Australia and Africa. They just come from a sun.
Dreams come from the sun? How do you remember something?
You close your eyes and think.
What part of your body do you do that with?
Your whole body.
Your whole body?
Hey, he's looking at me.
Yeah, he's always looking at you.
I think he likes me.
So how do children come up with these new cognitive methods?
Well, modeling is one way they can learn them. So sometimes they see other people doing something and they copy them. Another way they learn is by being told by other people. But a great many of the strategies are simply invented. The children are just thinking about the problem and they suddenly start doing it in new ways. You might think that children will only discover a new strategy if their old approaches aren't working. But it turns out that's not true. A lot of times you find that children have been doing perfectly fine with older strategies, and yet they still come up with new strategies.
Some children have exceptional cognitive skills at an early age.
A gifted child is defined as a child who has three characteristics. The first is precocity. That means the child has skills that emerge and develop at an earlier age than typical children and learns much more quickly in a particular area than a typical child. And that's really probably the most obvious characteristic, and that's the one that everybody would agree on. But I would add two others. The second one is what I call a rage to master, and that means these children are incredibly, intrinsically driven, motivated to master knowledge in the domain in which they have a gift. And the third characteristic is what I call marching to their own drummer.
You have more like less than 30 seconds left. Oh, you got an idea?
These kids are not just faster, they're also different. They don't just think faster, they think in different ways, and that means they come up with unusual ways of solving problems. And they also learn in a different way, and primarily they learn on their own. They don't need a lot of adult support or scaffolding.
Jean Piaget believed children reach a cognitive milestone called concrete operational thought between the ages of 5 and 7. In the Mayan communities of Mexico, 6-year-old girls are able to master elaborate weaving tasks and prepare complex winding boards, even though the board
does not bear a physical resemblance to the way the threads look when they're on the loom. So it involves mental transformation, which is the hallmark of concrete operation, to understand how you're going to go from this winding board, operating on threads on the winding board, to the loom, to setting up the threads on the loom.
Professor Greenfield believes this is a special period during which children are most likely to master cognitive tasks.
Between 5 and 7, my hypothesis is there's some built-in neural sensitivity to developing concrete operations, and that you will develop them in a particular form that depends on the particular stimulation. If they were exposed to a whole lot of different concrete operational tasks at the right age, they might learn it more general. And if we were exposed to weaving at the right age, we could probably learn to do it there too. But that if you are not exposed to those tasks at the age when that particular stage is developing, it may be harder to acquire it in those domains after the sensitive period.
Part of concrete operational thought is understanding that an object or thing can change while retaining its underlying identity, as Piaget's conservation task demonstrates.
Water Play-Doh science experiment.
Okay, this is like a science experiment. Okay, imagine we have some water here and some water here. Now, there are more here, or are they about the same?
About the same.
Okay, good. Now, watch what I do. You ready?
Now it's not close.
Okay, now look. Now start with Kiara. Kiara, is there more here? Is there more here? Or are they the same?
They're the same.
School-agers know that when a caterpillar turns into a butterfly, a biological process has taken place. and the caterpillar still exists in some form.
It's still a caterpillar because it was a caterpillar and it has the same personality as it did when it was a caterpillar, but he just looks different. He looks nicer and he looks prettier.
Me and my friend Josh went to the Bronx Zoo and a butterfly landed on my shirt. And I saw like it was a caterpillar, but it had wings on the side. I know there's something that stays the same, but I don't know what. I think that's some of what it was when it was a caterpillar.
Well, how do you know?
I'm not sure. I just have a feeling that it does. You're cracking me up.